my name is Dr. Smith, and I'm here from the VCU Biology Department. And I'm really excited because I get to talk to you about my favorite topic in the whole wide world, which is weed, right? So I absolutely love talking about weed. All right, so you guys are probably really familiar with marijuana, right? You kind of know what the effects are in humans. You know who's using it, right? You know about all the other drugs out there. Have any of you guys ever noticed that marijuana seems like a little different from the other drugs in some way, shape, or form, right? Like it's a little bizarre compared to maybe the opioids or alcohol or nicotine, right? Certainly it's got a lot of rumors going around, a lot of weird statements you hear about the drug. Okay, so for instance, has everybody heard that marijuana can cure cancer? Right? Right? Have you heard that you can't overdose on marijuana? Right? Have you heard that marijuana is not addictive? Right? These are all sort of things that you hear about this really unique drug. And I will tell you, some of those statements are totally true, and some of those statements are totally false. All right? So what I wanted to do today was kind of answer all of your burning questions about marijuana. But the problem is I've got 25 minutes and ain't nobody got time for that. Okay? That would take me like at least 3 hours. All right, so I was thinking about, well, how could I get to like everybody's questions? And I think the easiest way to do that is just explain to you how marijuana works at the molecular level. All right, that may sound kind of boring, and I'm probably sure a few of you just mentally checked out, right, as soon as I started mentioning molecules. But honestly, I can take this information and help you relate it to what you see in the whole person and the whole animal and sort of apply this knowledge. All right, so we're talking about a plant, okay? We're talking about cannabis, marijuana, weed, whatever you want to call it. And we all know that it has huge impacts on how the body works, including the mind, right? Does anybody have any ideas about why a plant, which could grow in a ditch, right, could drastically alter how the entire body works using just micromolar quantities of it? Do I have any students in here who would like to hazard a guess? Psilocybin. Oh, I see hands in the back that I know the answer. Okay, well the answer is the major psychoactive components of marijuana, like THC, are the same shape as things our body already makes. Okay, it's not magic. Right? The way all drugs work is they're just mimicking natural signals already found within the body. All right? Different proteins have different functions because they have different shapes. Okay, so the shape equals the function. Right? So THC, which is the main psychoactive component in marijuana, is structurally shaped almost exactly like anandamide in 2-AG. These are the endocannabinoids. Has anybody heard of these guys? Oh, just a couple people. Okay, so endocannabinoids are the marijuana that your brain makes. Okay, so your brain is actually making weed all the time, right? Endo means inside, cannabinoid is cannabis, so your brain is making cannabis-like compounds and using them all the time, right? So if you want to understand how these things work, right? If you want to know how weed works, you have to know what's going on in your own head first. All right, so most everything that your body does is the result of the actions of the cells within your body, right? So your body is really just trillions of cells holding hands and talking to one another all the time, okay? So, and they've got tons to say, all right? So everything you think, everything you feel, every movement you do, every symphony you write or soap opera you watch is the result of cells talking to one another. Okay, so cells are speaking with all of these different chemical messages, and other cells are also listening and reacting to those messages. All right, so the speaking is the chemicals within your body like hormones, neurotransmitters, and it's also drugs. Right? And in order for those messages to have an effect, they have to be heard. Okay, the proteins that help you hear those messages are called receptors. Has anybody heard of receptors before? Yay! okay? So receptors are the ears of your cell, and they're found on the cell surface, right? And they can hear all of these different messages. All right, we do have a receptor, and it's called the cannabinoid receptor. That's found all over our bodies. And interestingly, it's the most abundant receptor in the brain. All right, so if you're interested in how people think and feel, and you're interested in brain function, you really need to know this endocannabinoid system to sort of understand what's going on there. Okay, so right now, we're going to learn how cells talk to each other, and kind of specifically in the brain, just to make it easy, right? And what we're going to look at right here is we're going to learn about the synapse, and we're going to watch these two cells talk. Now, the place where two cells talk is called the synapse. Who's heard of synapses before? Right? So the synapse in this picture is this empty space going right through here. All right? The two cells that we have talking are on either side of the synapse. Okay? So this cell is before the synapse. We call it the presynaptic cell. This is the guy that's going to talk. All right? He's got a lot to say. And his messages are bound up in these little bubbles, right? The cell that's doing the listening is down here. He's at the bottom, and he's the postsynaptic cell, right? And lo and behold, he's got receptors on him, right? What did I say receptors were like? These are ears. Okay, so it makes sense that the cell that's doing the listening is the one that's covered in ears. Right? The cell that's doing the talking is the one that's got all the messages stored up in them, okay? And these are neurotransmitters, right? Neurotransmitters are things like dopamine, serotonin, acetylcholine, endorphin, okay? They can be just about anything. All right, so let's get ready to watch these two cells talk. All right, this usually starts with something called an action potential, which is a little spike of electrical activity. All right, you don't need to know too much of the details about that. But just know that we get some activity going on within the first cell, and we create this sort of electrical signal, and that causes us to release the neurotransmitters. Okay, so this is releasing the message that the first cell has. So this is how the first cell talks. Okay, it sends out those neurotransmitters across the synapse, and then they're heard by binding to the receptors on the postsynaptic cell. All right, and that causes the postsynaptic cell to have some sort of reaction, depending on what the message is. Okay, so if the message is something like endorphins, maybe we're going to feel wonderful and love everybody, right? Maybe it's something like epinephrine, which can also be called adrenaline, and that'd be like, oh, it's time to freak out, you know? So whatever the message is, it causes that cell to have that effect. All right, are we sort of okay with this? Are we familiar with this? All right, so this is something that you would learn on sort of the first day of a class about drugs that work on the central nervous system. All right, but this is only half of the story. Okay, I want to actually present to you the whole story, and that whole story includes the endocannabinoids, right, which is that brain's marijuana. All right, so we're going to look at this picture, and I know it's a little intimidating and complicated. This is actually done by a VCU student, Julia Moore. Okay, but it's set up just like the slide you saw before. Okay, so up here at the top, we've got the cell that's doing the talking, right? That's the presynaptic neuron. And down here at the bottom of this picture, right, we have the guy that's doing the listening. Now, the first part of this drawing on the left-hand side is exactly what you saw on the first slide. All right, so if you start way up in the corner, you'll see our nice little action potential arrow. And then you'll see these little bubbles sort of releasing the message, the little purple guys. And then it's binding to the ears on the postsynaptic neuron. This is the guy that's doing the listening, right? And the guy that's doing the listening is going to react to that message and do whatever it is he's going to do based on what he heard. Okay, but it doesn't end there. This actually is not a one-way conversation. This bottom cell down here can talk back, right? And that's exactly what the endocannabinoid system is for. okay? It helps modulate the volume of signals. Okay, so when we talk about talking to other people and speaking our words and getting our message across, the tone that we use is really, really important, right? So for instance, if I need a box moved and I tell somebody, can you please help me move that box? That's probably pretty good, right? That's probably going to get my message across and get sort of the actions that I need. But what if I run up in somebody's face and I'm like, I need you to move that box now? Like, is that uncomfortable? Yeah, that's bad. That's not so good, right? All right, so if cells hear messages that are too loud, that's very, very uncomfortable for them. Okay, neurons don't like loud messages. That gets us into the realms of things like seizures and neuroexcitotoxicity and neuronal death. Okay, so messages that are too loud can be really, really harmful and really, really destructive. So cells that are listening need to have a way to talk back and be like, hey, you need to calm down, okay? I got your message, right, loud and clear. I do not need any more of it. You need to tone the heck down. You need to back off. That is way too loud, okay? And that's exactly what the endocannabinoids do. All right, so this gets us into the rest of the story. All right, so here's our cell that did the listening down here, and he's had some sort of effect, but it's too much, and he's feeling uncomfortable, right? So he's going to create marijuana, right? Endocannabinoids. These include things like 2-AG and anandamide. Now these are going to go backwards. We call it retrograde signaling. It just means signals that go the opposite way from normal, all right? So that is really, really unusual and completely different from all the other signals that you would see in the body. And even more interestingly enough, the receptors, which are the ears that hear it, are actually on that top cell, right? That cell that originally started with the message. Okay, so those receptors are up there. The weed binds to that first cell and it quiets it down. Now, it can be really hard to see things working with sort of a 2D image like this. So my next slide is going to show everything moving. So I'm going to repeat everything I said, right, to make sure that we're all on board, and you're going to see it move so you get the feel for it. All right, so this is exactly like that first set I showed you, right? Here's this cell up here, right? Is this guy talking or is he listening to start with? He's talking, right? This guy is usually the guy that listens, right? He's got all those ears on him. Now, I want to add the endocannabinoids to this story, right? Who can remind me, where did the ears for marijuana, where are those located? Are they on the top cell or the bottom cell? The top cell. Okay, that is wild. That is completely different from all of the other signaling that we see out there. All right, so let's go ahead and look at what happens now. Right, so here we've got those signals coming in again. Here's our little action potential. That's going to travel down the neuron, and it's going to allow us to release the neurotransmitters. Right, so now we can release endorphin, dopamine, serotonin, epinephrine, norepinephrine, histamine, glycine, glutamate, whatever it is that the message is. Okay, that's going to float across the synapse, and it's going to bind to those receptors on the postsynaptic cell, and that causes all the effects. Right? But maybe this signal is too loud. Okay? Too loud is very deadly and can create a whole lot of problems. Okay, so if this is too loud, this cell that's listening is going to be like, okay, that was too loud. I am totally freaked out. All right? So it can respond to that by creating weed, which is awesome. It actually creates it out of membrane precursors on demand. Don't worry if you don't have those details down, but it makes weed, literally. It makes anandamide and 2-AG. Right? These guys go backwards. All right? This is actually the cell talking back. Right? So now this can bind to those cannabinoid receptors, and it can say, yo, dude, you need to cool it, right? Like, I got your message. You need to stop sending me neurotransmitters. It is way too much. All right, tone it down, And that way, you don't need to yell at me. We can all tone it down. We can reduce that. We can reduce the effects. All right. I don't have a lot of time, but does anybody have a quick question about that? We okay? Okay. All right, so that is how cannabinoids work sort of in the brain, right? But another really important thing that you need to know about the cannabinoids is that they are found in high abundance all throughout the rest of the body. Okay, so this is not just a brain thing. All right, you can find lots of CB1 receptors in organs like the gut and the liver, where they have a lot to do with feeding responses and energy balance and how we store our fat. Okay, we can also find them a lot in the reproductive tissues, all right? So they're important in menstruation and pregnancy success and sperm development, and they're found just about everywhere else too. So this endocannabinoid system, the body's weed system, is massive and plays massive roles throughout the entire body. So I've just told you a lot of technical stuff, right? And right about now, you're probably thinking, so what? Right? So what? Right? We're reducing neuronal signals. Right? What does that actually mean in terms of what I'm seeing in humans and all of these sort of weird statements we hear about marijuana? Well, one of the first ones that I like to point out is whether or not you can overdose from THC. Right? Who thinks in this room that you can overdose from THC? Who thinks that you cannot? Right? You guys are super smart. You can't. Right? Like a normal, healthy individual cannot consume so much THC that they actually kill themselves. All right? So in that respect, it's kind of a safe drug on that level. Now, can you do extreme things to get around it? Right? Like, yeah, you can, but that would be very rare. Now, why is that? Well, it's because THC and the endocannabinoids are not usually the original signal. They're more like the volume control. Okay, so this is not the signal that tells your heart how fast to beat or whether or not to beat. This is not the signal that tells you how much you should be breathing. Okay? It's adjusting those signals. All right, so because it's more of an adjuster than an actual doer, it's hard to actually die by adjusting the signal, right? You're not actually, completely turning on and off heart rate or breathing or anything like that. Okay, so it is sort of relatively safe. Another one that I get a lot of questions about is, hey, is it really good as a medicine? Can you actually use it in things like cancer and other sorts of things? Yes, big time, big time. Okay, so this is a quiet down signal. And if there's any cells that are being loud and noisy and doing a little too much of stuff, it's cancer cells. Okay, so marijuana is really good for getting, cells to sort of slow down their growth. And it's also useful in tons of other situations, right? Because the endocannabinoid system is everywhere, right? It's in the gut, it's in the hormones, and we can adjust those things using those methodologies. Now, there are major limitations to that, right? Because if you've got something that's turning everything on, there's going to be a lot of side effects. So it's a very tricky field to be working in. It's going to take a lot of years of adjustment. And just little PSA, right? Don't try to smoke weed to prevent cancer. It's not exactly how it works. Really. Okay, so I've got 5 minutes left. And I've got a captive audience, so I'm going to take just a couple minutes to get on my soapbox about something that's kind of near and dear to my heart, right? I'm a mom, and I have 3 little kids at home, right? I've got a 3-year-old, a kindergartner, and a 3rd grader. So a large part of my past 10 years has been involved with pregnancy, breastfeeding, and keeping babies alive. Yeah, right? So if anybody in here has been pregnant, right, you guys might know that there are these apps on your phone, and you can sit around and talk with other pregnant women, right? Like, hey, we're all 12 weeks pregnant. I'm still barfing. My feet hurt, and I'm having a meltdown. There's a lot of that going on, right? But the other thing I noticed is a lot of pregnant women talk about smoking weed, like a lot. And when you look at the statistics, there are a lot of pregnant women smoking weed. right? So that's kind of interesting. And reading all of these other moms, I sort of get it, right? So pregnancy comes with a lot of nausea and vomiting, like a lot. And it's a really painful, sort of stressful time for a lot of folks, okay? And a lot of women might not have great access to health care. Maybe they can't afford it. Maybe they don't have time for that, right? Maybe they're distrustful of the medical system, right? So think anti-vaxxer types, right? And they're looking for sort of natural, empowering ways to treat their nausea and vomiting at home. All right, do you think that using marijuana during pregnancy is probably relatively safe or relatively harmful? Who wants to go with relatively safe? Who wants to go with relatively harmful? Yeah, the harmful folks have it, right? So marijuana is getting into your brain, it's getting anywhere, it's getting all through the fetus, right? And it has major, major effects on the brain, right, and major effects on the body. And of course, those disturbances really disrupt how the fetus develops. Okay, so we've got tons of wonderful animal research in mice and rats showing how pregnant moms who smoke marijuana during pregnancy, it definitely changes how their brain develops during the fetal stages, and those brain changes are seen well into late adulthood. Okay? We also have a few human studies which are showing the same thing. Okay? So long longitudinal studies where they're tracking these humans over time, and the disturbances we see look almost like exactly like the huge disturbances we see in the animal models. So with my last minute, I would just like to say, hey, everybody who's thinking about weed, think about those pregnant moms and make sure that that's the new message that we need to get out there. We've got the research to show you that's no good. All right, so be careful. All right, well, thank you very much. I have enjoyed getting to speak to you guys, right, about weed, and we'll take questions later.